Welcome to the Futurati podcast. Any member of the Futurati is somebody who believes in the power of the future. We know there's a better world ahead, and we indeed have the power to make it so. In our podcast, we talk to the best minds in the world about the most urgent problems facing mankind today, and we hope you learn as much from them as we do. I'm Thomas Fry, a professional futurist and keynote speaker.
And I'm Trent Fowler, a machine learning engineer and author. Thank you for joining us. Good evening, everyone, and thank you for listening to the Futurati podcast. Tonight, we're joined by Joel Chan. Joel is an assistant professor in the University of Maryland's College of Information Studies and Human-Computer Interaction Lab, and senior fellow at the Center for Advanced Study of Communities and Information. His research explores systems that support creative knowledge work, particularly ones that are open and sustainable. If you enjoy this interview, please don't forget to like the episode and subscribe on YouTube or wherever you get your podcasts. Joel, thanks so much for coming on the show.
It's a pleasure. I'm looking forward to this.
Yeah, why don't we hear a little bit about your background, your interests, and what brought you to working on the problems that you're working on?
Yeah, so my start in this space began in the world of psychology. So I got my PhD in cognitive psychology, and I was actually interested in learning sciences when I first started, how to build interventions and tools to help people learn better. And you'll see that color the way I think about things all throughout, even though I've kind of strayed from that core topic. But funny story, my advisor in my PhD program didn't have money for the thing I wanted to work on, which was peer support for writing. And so he said, well, I've got this grant that's going to last for 3 years, and we're going to work with some engineers and figure out how to make them more creative. If you hate it, we'll get you off right away. If you don't really like it, we'll figure something out on the side. But if you love it, then all's good. And turns out I loved it. It was really, really cool to think about this kind of messy problems in this space of sitting engineers down at a search engine and trying to have them think about what are other ways I can think about problems in creative ways. And at the time, I didn't know that HCI existed.
Right.
So it was straight up in psychology, even though it was an interdisciplinary program where we had kind of policy people, learning scientists, and psychologists all in the same space. I didn't know HCI was a thing until my dissertation, where I stumbled upon somebody from Carnegie Mellon. So I was at University of Pittsburgh, and he had done a lot of work on design stuff and had visited our department. And turns out he was working in the space of HCI, and it was like, wait, this thing that you're doing, trying to understand how people search for information and building novel interactions to help people find inspirations is HCI. So I was like, that's cool. And so he was on my dissertation committee. We were looking at a platform for innovation contests and studying how people build on each other's ideas and trying to trace and predict which ideas will do better than others based on what kind of knowledge they built on. And then I went on to work with him on crowdsourcing stuff. I did a postdoc with him for a couple of years at Carnegie Mellon, and then discovered even broader world of information science, where I basically have license to pick whatever theory I like and whatever method I like to study this giant problem of creativity support systems, where I think about systems much more broadly than I used to in my PhD, where cognitive psychology is much about the individual mind, thinking about cognitive mechanisms of discovery and how memory works and things like that. I broadened it when I went to HCI to think about the interface between an individual and a computer system. And as I've gone deeper and deeper into the specific domain of scientific discovery, trying to support cross-disciplinary innovation and things like that, really started to think about the larger context about, there's only so much you can do at the interface level if the underlying structure of the things you're trying to index in terms of papers and patents and things like that is not structured the way that it needs to be for you to be able to interact with it usefully. And so then thinking about broader systems of how we build the infrastructure for disseminating knowledge and sharing it amongst people, as a point of intervention to think about how do we build systems and contexts that we can put people in that enables them to do their best creative work. So along the way, I've picked up a bunch of different things. I've started to dabble in applied machine learning as we've been thinking about how to build these tools better, but also picking up theories and concepts and methods from social sciences, thinking about how infrastructure is developed and how people cooperate using computers. So that's where I am today, and continue to retain a core focus on the domain of design. So I'm still working with mechanical engineers, trying to model aspects of how people solve problems, but also increasingly I'm stumbled into the field of metascience, trying to think about how to make science better. And there's a subsection of metascience that's not about studying how it is, but kind of metascience, applied metascientists is the term that we, call ourselves. People building tools like Cite and connected papers and all kinds of interesting, all kinds of tools to improve the way we think about scientific problems and collaborate. So that's a brief history of where I've been and where I'm at and where I am now.
So a few years ago, I gave a talk at the Library of Congress for the American Library Association. And so they're in kind of the business of archiving lots of things. And I proposed this notion that what if you learned how to archive ideas as the kind of the core element, the atom, if you will, of larger concepts. And then I was playing around with what exactly is the anatomy of an idea and what elements do you need to make it a full idea. And then thinking that if we put all these ideas together, then they would all bounce off of each other and create new ideas. And then even if only 1% of them rose to the top, that would be this rich, fertile territory that we could mine for other things. Conceptually, it makes sense in my head, but I'm not sure it works in any other level in the world.
It's a very, very compelling notion, right? Like if you were able to somehow capture and make available, right, a bunch of ideas and provide ways for them to intermingle at higher rates than the kind of straw of talking in a conversation, right? Because right now, as we're talking, right, we are sort of trying to construct these pictures of what you have in your head and what I have in my head, and there's this kind of buzz factor between that's super lossy, and I can't tangibly interact with the ideas that you have, and so in that way, it's limited, right, in terms of what's able to go on between our heads. And so the traditional way this happens is we have to spend a lot of time together, right, and form a collaboration, and sort of our ideas start to intermingle as we work together a lot more. And then we can start to really make new and interesting stuff out of the kind of intersection of our ideas. And right now, that's pretty slow, pretty inefficient. It works really well when it can happen, but it takes a lot of time for people to kind of form these collaborations, build trust, and so on. And so it's not a pipe dream, though. So like I mentioned, my dissertation was studying this innovation contest platform. It was a spinoff from the IDEO design firm. It's called Open IDEO. So they built this platform for social innovation. And so people would post, ideas basically on the platform, and they had one ontology, right? So they had like inspirations versus concepts, right? So inspirations would be any fodder for ideas, right? Like user research and analogies and so on. And then concepts would be like, I'm developing this idea for this platform. And what's interesting is they had a mechanism for you to be able to cite ideas. So you can say, I'm reading this thing right now, I'm going to build on it. Right, and can kind of cite that in a new idea,
like a block reference for ideas.
Exactly right. And there were no backlinks though, so it was just a one-way kind of thing. But that was like a step up. That's what I exploited for my research, to try to understand, trace the lineage of ideas and so on. And so in that way, it was kind of similar to how we have the ability to cite papers and kind of trace that as well. And a persistent problem in these innovation contest platforms is how do you navigate, how do you search through, how do you kind of trace? Um, because you're right, like one of the fundamental problems is how do you represent an idea at a level that's useful, right? So a lot of these concepts vary very widely in terms of their granularity, right? Some of them are super long, like a really, really long document
Right.
that actually had like 5 ideas in them, right? And so if you cited that idea, what are you citing? What are you building on? Normally, it's like just one small piece of it. And so it became hard to kind of like see the big picture. You have this kind of flat list of ideas, and maybe you can sort them by number of likes, number of comments. Maybe you can add some tags to them, but it's too coarse, right? You want to see the structure of the space, right? Where is the white space? Where are the clusters of ideas that we're exploring deeply? Where are the kind of new, interesting combinations? And that's still an open problem in the field. Like, how do we synthesize a large number of ideas so you can see the structure of the problem space and thereby get more insight than simply aggregating a bunch of the ideas. And yeah, so it's lots of people working on it. It's a still an open problem, but I think the payoff is very large if you can figure that out.
Yeah, one of the things that we played around with in the past is this idea of if we have flying drones that are flying over cities, they're going to start creating as they're surveying the city, they're going to create digital models
Yeah.
of the city. And I think this opens the door for search engines for the physical world. As we add more and more sensors to these drones and to the physical surrounding, suddenly we'll be able to search on things. I want something that tastes like this or smells like this or something that has this
Fascinating.
texture or this harmonic vibration or this specific gravity. Or this level of humidity, whatever
Yeah.
it might be, and you'll be able to search on all these different
Right.
attributes that we don't have to know how the search engine is doing all of its work in the background. We just have to know that we're getting the right answer once we put in the query.
That's fascinating. Yeah. Yeah, there's so many aspects of ideas that, if you can think about them as attributes, right? Like what it smells like and so on, that are apparent to humans when they kind of see it, but are not available for indexing, as it were, right? Like
Right.
we've got these like search algorithms and so on. They're very powerful, but like I said earlier, they're fundamentally limited by the structure of the data, right? Like, so if it's completely unstructured text, that's only text, right? Not multimodal. You're missing a ton of information that, say, you and I might glean from if we were in a brainstorming session together. We have a sense of how the idea feels, where it was in the conversation, how people responded to it. There might be some artifact that represents a sketch or a rapid prototype, and all that rich affordances of the idea are just gone if you kind of compress it into a textual form, unless you're a really skilled metaphor writer, I guess. Yeah, so in that sense, I do see the connection of like, how do we not just find, it's not just about finding the right level of representation, but also thinking about what are all the aspects of ideas that make them fertile, that make them useful, that people want to search by. It reminds me of a very random anecdote of so it is, speaking of librarians, one of the projects at my current institution that was famous was this international children's library, digital children's library. And during their user research, they found that a frequent thing that children would like to search books by was the color of the cover, right? Or like the way it made them feel, right? And so like they added those metadata to books, right? Because that's how children remember which books they enjoyed and so on. It's like that one book with the blue cover that made me feel this way. And so they set up the library so that was a metadata field for the books, as opposed to just like the author, year, and so on. So I like the idea of like reimagining all the different ways we can sort of skin the cat, as it were, for these ideas.
So what do you think an advanced version of a platform like this might look like? You've spent more time thinking about this than almost anybody. So, given the limitations of our current tools and how pressing the problems we're trying to solve with them are, what do you think will come out of those efforts?
Yeah, I think there's a couple of different angles that we're shooting for, right? As a field. One I think has to do with the being able to provide a sense of global structure, right? So to get a feel for, so people I work with, clients, talk a lot about wanting to know about um, trends and clusters and white space and having some insight into sequences of ideas and those kinds of things. And so that depends on having insight into the structure of the ideas. But platforms that could say, ingest, say, ideas from 5,000 people, right? People are kind of like, you put out this huge call for a hard problem like the X Prize or something, right? And people put in tons of contributions. You get value from the individual ideas, but sometimes you get almost as much, if not more, value from just understanding the structure of the solution space that gives you a sense of, here are some open problems, here are some promising avenues, and so on. And so platforms that are able to provide that level of global structured insight, I think are still somewhat far off, but not not impossible. And that's kind of like one of the big value propositions that people who work on this problem are shooting for. Another aspect of it is having ways to connect pieces of ideas that are maybe not sufficient on their own to combine into something bigger. And so this is kind of where the idea of analogy comes in. If, say, you and I are working on related problems, but we use different language, and we have, you've got some solution that I don't, and I've got some insight that you don't. There's a lot of value in a platform being able to figure out that we should talk to each other, right? And specifically about these pieces that we have that might make sense to come together. And so a platform that understands, again, like the attributes and aspects of ideas and figures out how they can relate to each other in non-obvious ways, I think is also a big value add.
So that sounds like kind of a hard problem to solve. So what would it mean to parse the attributes of different ideas, so you could kind of match them?
Yeah. So I think you're reading one of the papers that I've been a part of that describe the idea. Like one concrete example is ideas often have the attributes of it's trying to solve some problem and it has some mechanism, right, for achieving that purpose. So, like for instance, one of the problems that I use for experiments is how do you generate electricity in remote places using only human motion, right? So the purpose of any idea for that problem is going to be generation of electricity, and then it's going to have different mechanisms for it, like leveraging translational motion or translating rotational motion into some kind of flywheel or something like that, right? So in that sense, like if you have an idea, like I'm going to propose that we build a thing that leverages this accelerometer and so on. It has those kind of sub attributes of like, this is a purpose that it's trying to solve, and this is a mechanism that it has. And if you're able to, what we've shown is that people are pretty good at noticing these things, these aspects of ideas, and they're good enough that we can kind of train lots and lots of people to look at ideas and then kind of label them in terms of these attributes. Like in the product description, this part is talking about what it's trying to do. This part is talking about how it works. If you do enough of those labels, we can train a machine learning model to kind of ingest a product description and then kind of build two word embeddings, essentially, that identify those aspects. And that turns out to be very useful, right? So you can say, all of you, if you're working on this problem, here are a bunch of different mechanisms for solving similar problems. So that's kind of a concrete example of attributes that might turn out to be useful.
So I was reading that paper, and that's scaling up analogical innovation with crowds and AI. If anyone's interested in looking into it, it's fantastic. And I was sort of interrogating the ideas throughout, imagining how it might apply to more abstract problem spaces.
Yeah.
Because for better or worse, that's just kind of where I'm at.
Yeah.
I tend not to be thinking about how to generate electricity in rural Kenya. I'm thinking more often
Right.
about, like, Thomas and I are associated with a quantum computing startup accelerator, and so one of the things we're thinking about is, like, well, how do you validate companies as they come through? Like, how do you validate their underlying idea, their underlying technology? Like, how do you spot that? That seems like a more abstract problem, and I found the results in the paper very compelling. And I'm sure we'll spend more time talking about it in a couple of questions. But I was just wondering if you'd given any thought to more abstract things like that, or philosophical concepts like ideas of justice. Like, how do you promote those things? It seems like this system, the schema, mechanism, idea that you have, it wouldn't map as well onto problems like that.
Yeah, I think you're right. Right, like that's that particular schema, I think, is a instance of the search for intermediate levels of structure, right? So what we're reacting to is in the early days of kind of good old-fashioned AI, we had these knowledge-based systems where if you represent the ideas fully in terms of their concepts and relational structure, you could do a lot of things with them. A lot of things. So any particular concept would work well. And so kind of this purpose mechanism schema, I think, works well for these kinds of more concrete problem-solving questions. I think is a good open question how this might extend to. It seems like you're talking about two different axes of generalization, right? One is kind of turning the complexity dial up to, like, quantum computing, right? So kind of more higher level complicated ideas. And in that sense, I think the schema could be extended in principle to say, if I was thinking about what is the problem that, say, policymakers face for trying to control the spread of a pandemic, right? They're trying, and there's kind of underlying abstract ideas of trying to persuade, to inform, to influence behavior, to control the spread of something, to balance trade-offs. And at that level, people are fairly good at identifying, like, they're noticing, like, this is a common schema, right? So if you're trying to, like, this analogy actually was kind of very explicitly drawn between, say, how to persuade people who suffer from risk of AIDS. How do we persuade them to kind of change their risky behaviors? Kind of draw that analogy to how do you persuade people to manage their risk when it comes to COVID? And then they were drawing lessons from what worked and what didn't work, right? So they're able to map, right, the underlying problem structure of how do you get people to change their behavior under situations where risk management is uncertain, and then what are some of the solutions that worked and didn't work. The other axis that I think I hear you saying is kind of, you mentioned abstract concepts of justice and things like that.
Yeah.
That is fuzzier to me. It's not obvious to me. And I think the first thing I would ask is what would be useful things to do in terms of connecting? What are some useful axes of the concepts themselves that humans pay attention to? And then that would help sort of think about what are some intermediate levels of representation that we could try to recognize in these ideas. So I'm not quite sure how to think about it yet, but that's the angle of attack I would go for, is like who is thinking about these abstract concepts of justice, and what are they trying to do, and what are the attributes that they pay attention to, that they find important when they talk about it, and things like that. So that's the kind of general process of how we would decompose this thing into a problem that you can solve.
We've been doing quite a bit of work lately on systems thinking, and so every system has an overarching function to it. And when you start dissecting the system, you start tearing apart the component parts and the overall purpose of it, and what's the user community, and who does it affect, and then how does changing an interface one way or another affect how it how does it affect the overarching function of it, and then And so we we have a whole lot of systems in our in our world that are breaking
Yeah.
down right now, and so we have to think through how do we modify these systems? How do we make them better? Because they're just not going to be functional for
Yeah.
much longer. And I won't name all of them, but there's a whole lot of
Yeah.
them out there.
Yeah. Yeah. Definitely. Um, Definitely. And yeah, there's a couple. I mean, I think there's one bifurcation between people who may think that the problems that we face in terms of reforming these systems have less to do with knowledge and more to do with coordination and collective action. Like we have a pretty good idea about what things we can do to fix these systems. It's just hard to coordinate or get people to agree on those things. And so it's in that sense a coordination problem. And then there's kind of a different way to frame it is like it's for any given system, there are many ways that it could break, and it's hard to understand precisely what's going wrong and what are the possible ways that you can fix it. And then in that sense, you kind of frame it as a knowledge problem. And then you can think about, well, um, who understands the parts of the system, even if no single person understands the whole system, and how do we put these together into a useful model of the system that allows us to then say, well, what other systems are similar that maybe have overcome these problems in the past. I'm not sure if you're aware, not sure which systems you have in mind and whether any of those have analogs in the past where the problems have been solved. But if there were, then that would be like a useful thing to do, assuming that we don't already know the answers and that we just have to figure out how to coordinate to implement them.
I find that a really interesting idea, taking people who understand the different parts of a
Yeah,
complex system and sort of merging their understandings together. Like what tools are available to do that kind of thing today? And I mean, Rome arguably is one. I'm in Rome Book Club 5 right now, and we're kind of exploring,
yeah, yeah,
community graphs and stuff like that. But
yeah.
I wonder if there's anything you find that compelling in that space.
I'll start with the things we know work the best right now, even if they're not the most efficient, right? So one of the very concrete areas where that played out was in pandemic response that required both virologists and aerosol scientists and epidemiologists to kind of come together and say, okay, if we understand that the virus has different sizes, how does that impact the kind of physics of it? And so you have these like aerosol scientists who may know nothing about viruses, but they know a lot about how kind of these microparticles diffuse in a space, and that's super important. Turns out for thinking about interventions and so on. So for a while, probably too long in my estimation, there was not a lot of good communication between them. And then what happened was the National Academy of Sciences convened a bunch of these people and say, let's sit down for 1 week and hash it out. Right. So that's current. I think the current gold standard, like I said, is like the best way we know how to do this kind of let's piece together fragments of understanding that we each have into a coherent whole is to get us together in a room and have us talk to each other, hash things out, and write stuff together. And so that's fine when it works out, right? But there's lots of barriers to finding each other in the first place, right? And so economists, they talk about search costs and execution costs
Yep.
of innovation, right? And so the search cost can be surprisingly high, right? So even within the same institution, right now, there's huge number of connections between people that are just untapped. And one of my favorite experiments, they did a very simple intervention where they brought people together and they randomly paired them up into different poster sessions, and they found that the likelihood that people collaborated who should have collaborated years ago, even though they were maybe just like one building over in the same university,
Right.
but they never knew about each other.
Wow.
And yeah, there was another study that looked at the impact of construction work on French university campus. And there was a kind of natural experiment for labs who were forced to move around. And there was a huge penalty to labs collaborating who are far apart in terms of knowledge disciplines when they were forced to move far away from each other. But labs that were pretty much in the same discipline, there was no cost to the quality of their work when they were forced to move apart, which again like speaks to like there's something about the kinds of interactions that happen face to face that are really, really conducive for this kind of piecing together. That it's not clear to me that it works as well in non face to face settings that are asynchronous. And so again, like I think systems like Roam and others that are attempting to figure out ways that people can externalize some of this knowledge to kind of help each other find pieces of it and build on each other, I think are moving in the right direction, right? So Roam to me is the next evolution of the kind of older idea of federations and federated wikis, right? To have this different mechanisms for, instead of just disseminating ideas and having people upvote and downvote them, you provide ways for them to build on each other and allow them to talk through their ideas. Twitter gets a little bit at this, but it gets there's like kind of a depth limit to it that doesn't quite work, and it's also got I think counterproductive attention incentives. But you can see glimmers of what can happen. Like I've received a ton of really useful inbounds connections from Twitter over the last year as I've started to engage more. There's something powerful about a network that allows people to kind of share pieces of knowledge.
We've played around with this scenario that if somebody were to create a wearable AI that its sole mission was to detect danger, because everybody's constantly looking around for what's a possible threat to me, and am I in imminent risk here or imminent danger, and so having an AI that could actually detect everything from a predator to a dog with rabies or a tick or somebody who's a hacker that's going to hack your computer, being able to detect this full range of possible dangers, I think is a real interesting kind of thought experiment to work through.
There's at any given time, my mind immediately goes to if it wasn't as necessary for you to be monitoring so many different things at once, what does that free up in terms of what you're able to do? The first place my mind goes is what happens to people when they're able to get a handle on, say, anxiety, right? The mental cycles that are spent kind of monitoring, different cycles and different vectors of potential threats and so on, and the amount of cycles that are freed up if you're able to sort of offload that makes me think of in a social setting, in a brainstorming meeting, for example, psychological safety is super important, because it kind of like, if you are not constantly, in addition to thinking about what people are saying, you're trying to monitor your status in the conversation, and those kinds of things, like how does that drag things down? So it's interesting to think about, like I'm riffing on it to think about like mechanisms for programming or shifting our attention or offloading our attention in useful ways.
Well, it actually dovetails with a question I was going to ask. So your response to my last question was that it's pretty hard to beat getting everybody together in a room and whiteboarding and talking face to face. And I wanted to follow up by asking you about how machines might help some of that, solve some of the problem of asynchronous communication, or identifying when two people are talking about the same thing semantically, but in different terms. And if you could have a wearable AI that maybe isn't scanning the environment for threats, but that is just cataloging all the things you say, right? And it's just breaking those down into concepts, and is noting that similar sorts of conversations are happening elsewhere. I mean, there's huge privacy concerns, but if we just allow ourselves to abstract that away, there's some real.
So you're asking,
potential.
how does collaboration evolve over the coming years?
Yeah, and I mean, there are people who seriously put forward the idea that someday every word spoken will be recorded, or some huge fraction of them, and it will just be kind of part of what you do. You just know that when you talk, it will be recorded somewhere, and most of it nobody will ever go through. But if you had the right algorithms, I mean, you could. There's a lot you could do with that, right? You could trace sentiment in real time. You could almost monitor the spread of memes, like you monitor the spread of pathogens. You could connect people in interesting ways if they're having similar conversations, where it's like this person is talking about the same idea using entirely different words, but they are trying to get at the exact same thing.
Yeah, and are there beads of sweat forming on his forehead?
Does he have a knife? Does he? Is he going to attack you?
I want to riff on that last comment a little bit, right? So this like beads of sweat thing. So one of the things that I think is there's a couple of different ways to think about computer mediated communication, right? So one is a fairly difficult hypothesis to beat, which is that face-to-face is just superior because of the kind of richer channels of signaling that you can kind of follow. But I think it's really interesting to think about how machines can augment different channels of information that maybe can go beyond what is accessible to you in a face-to-face setting, right? So like beads of sweat might indicate, or the AI might be able to have monitoring the kind of cadence of conversations, right? To get a sense of the energy levels of the conversation, and then maybe kind of suggest ambient interventions, like as the conversation starts to steer towards a place that could be unproductively tense, maybe it starts to trigger ambient lighting that reduces the mood or something like that, or maybe it helps with people who have trouble reading cues through Zoom, for example. I was thinking about there was a colleague of mine who was working on tools to help international students learn how to read cues better during their teaching. Okay. And so they had this kind of connect that was able to sense the room and give feedback to the student as they kind of train themselves to understand like how they were coming across, how the students are reacting, and using that data to kind of talk with advisor to get better at reading these cues.
So it occurs to me that the core question is, how do we make a virtual communication actually superior to meeting somebody in person?
Supplementing, like making virtually mediated communication less arid somehow, like making it so that it's more lifelike.
Correct. It's so I don't know if I don't think that's a pure AI question, but in a sense, like it is, because you need to augment the ability of your sensors, right, to kind of pick up on different, not just physical signals, but also to attach higher levels of meaning to them, right? The difference between sensation and perception. And so in that sense, I think like developing AI is not just to mimic what humans are picking up on, but also to identify, like you said, what are some untapped channels of information that are not available to human senses that could augment communication in a way that's possible only when you're virtual. That's it. I think that's an interesting design prompt, and like to me, that's like a more provocative thing to think about than to say, face to face is always going to be better, and we can only try to match it. And then I think that kind of boxes you in to try to think about how do we replicate face to face communication in a virtual setting. Right. And I think that's kind of where a lot of virtual conferences right now are stuck, trying to think about how do we make it like an in-person conference, instead of thinking what is available to us now that we're not in the same room. How do we, like, one of my favorite ways of thinking about virtual conferences has been to drop the idea of an intensive 3-day conference altogether and just say, what if we accepted the fact that we're asynchronous and we're all not able to take all this time off? How do we build systems that augment this kind of ability to distribute your conversations on a longer time scale? Or if we remove the constraint of everybody needing to watch the same Zoom talk right now, what kinds of interactions are are enabled. And that was a philosophy conference, I think, that had been online for like 3 years. There's a huge contrast to I don't know why
philosophers have more time to spend on this
they have
kind
more
of thing.
time to spend.
They don't have a business problem they're trying to solve, right?
Yeah, exactly. I've been super frustrated with a lot of virtual conference experiences right now, right? Because in a sense, they're kind of stuck in the first paradigm of trying to figure out, first face-to-face is the best. How do we replicate it, as opposed to how do we think differently about what's available in the virtual setting.
It would be very disappointing if we didn't spend some time on Metascience. And so we just recorded an interview with Jeff Anders. I believe that was the last one we did. And he is at the Leverage Research Institute, which you should check out if you haven't heard of them. And they do a lot of work on metascience, knowledge in society, knowledge production, that kind of thing. And they wanted to, when they decided to address themselves with the problem of understanding how scientific discoveries arise, they began by studying the history of science, and they're studying the history of electricity now. And I thought this would be sort of an interesting way to come at that same question from a different angle, because you're also interested in that, but you are spending more time thinking about the tooling and the infrastructure and how to make those things better. So why don't you just use that as a springboard to riff on that area of your research a little bit?
Yeah, it's funny you bring it up, because I'm actually doing we literally 2 weeks ago. So I'm working with Matt Clancy on a writing project, trying to unpack the different dimensions of cross-disciplinary, cross-boundary innovation, and trying to kind of bring together 3 different perspectives, one of which we're missing. So the first one is kind of this like quantitative, you study a bunch of citations of patents and papers and so on, and try to understand how the lineage of an idea of a paper, for example, predicts its impact and so on. And then there's a different kind of area of study where they look at individual inventors and scientists in real time. They kind of observe their meetings and so on, embed themselves using ethnography and so on, and try to trace what's happening without the, distortion of retrospective bias. But the thing that we're missing, that both Matt and I are missing, is rich historical case studies, right, of like individual inventions and how they were traced throughout history. And so we're both on the progress studies Slack. With Jason Crawford, So we posted it. We know that Antoine House will know about this, and so we kind of posted that question there, and we got a bunch of book recommendations. But yeah, it's I think where I want to go with that is something I think a lot about is take, for instance, there's a pretty reliable empirical finding about the trade-off between levels of distance. So, in order for you to have high impact, for example, this paper by Uzi and others, I think it's called Atypical Combinations and Scientific Impact, where they trace, what profile of citations predicts whether you're going to be a big hit of a paper, right? And it's the answer is having some very unusual combinations, but also a lot of conventional combinations, right? So this idea of like having some novelty, but not too much novelty, or some distance, but not too much distance.
There's a theory in the philosophy of religion that part of what helps religions spread is if they are just new enough or just unbelievable enough, people are like, well, is that serious? And then it kind of like occupies more and more of the space in your mind until eventually, you're converted 2 years later.
I think that's kind of a similar idea for sure. So as a tool builder, right? Something I think a lot about is, say we were able to, we really looked into this and this kind of showed up again and again and again and again. I think a lot about how much of that is a kind of historical accident of the way that knowledge institutions are structured right now, right? Because you could plausibly say the reason that you need to have some novelty but also some conventionality is to placate reviewers or your peers, right? So they don't dismiss you out of hand, but the conventional combinations are actually epiphenomenal. Like they're not important for the idea at all. It's a chore you have to go through because of the way that society is structured right now. And for that, I'm super curious about like a historical perspective on that kind of what I appreciate about history is that it helps us understand that the way things are right now is not always the way things were and not always the way things will be, right? And so like I think it's paradoxically for some technologists who build systems, they'll kind of like take the system as given, right? Like, we understand this empirical regularity, so we're going to design ways to help people encounter ideas that are kind of a mix of conventional and novel. But in the back of my mind, what I really want to know is if we combine all these historical case studies and try to look for variations, can we think about different ways that we could structure society where this empirical regularity will not show up? Then we can think about like different kinds of interventions, right? How do we structure, say, the structure of a knowledge institution such that you don't need to go through the facade of making these conventional combinations and talking about things in conventional ways. You can just kind of go at it. Is it like a limitation of the idea filtering system, that kind of thing. And yeah, so Matt and I talked a little bit about that, and that's something I wonder a lot about is if we take that long lens, how might we see things differently? That's something I think a lot about in terms of metascience, right? It's often very tricky to tease apart kind of the is from the ought, right? And the descriptive from the prescriptive, right? Because you can't run randomized controlled trials on all of science. And then if you get at that question with simulations, right? Like what if the reviewing system was like 5% less noisy, or what if prestige didn't matter quite as much, or things like that? Then you kind of have these counterfactuals that you can compare. But then it's very plausible to say that there's actually no connection whatsoever between that little model that you built of the simulation and the way that science works in reality. And so what I want is to be able to kind of join that kind of how could things be different thinking from the simulations with any data, right? That's able to, and that's what keeps me up at night, because I'm worried that, maybe we're stuck in a local optimum, right? The way science works right now works well enough. And maybe there's like really much better ways of doing things that we just don't know about, because we don't kind of take the historical lens to question how things could be different.
What are some ways? What are some ways you think that science might be improved, like the production of scientific knowledge might be improved?
Yeah. So right now, thinking the obvious answer to your question, one answer to your question is a lot of people are kind of upset about the PDF and the paper being the central means of communication of scientific knowledge, right? Right. And so you can very plausibly say, well, what if that weren't the case, right? What if there was like really robust infrastructures of sharing computable knowledge, right? Like where instead of everybody compressing this complex knowledge, structured knowledge into this unstructured narrative, they additionally, did semantic publishing, right? Like they drew from ontologies, and they talked about, like, instead of saying we studied these rats, you would like kind of reference the ontology, Wikidata or some ontological label for that rat, and so that allows us to kind of build this knowledge graph in real time. And then you have this like kind of living systematic reviews that update as new findings are added to the literature, as opposed to people having to kind of spend hours and hours and hours to try to extract it from PDFs and then do it all over again. So that's one way that I think you can think about, imagine scientific communication being different. Like where I think that connects with is we have these ideas about the growing burden of knowledge, right?
Right.
Ben Jones has been kind of tracking a lot of different aspects of this in terms of the age of first invention, or the age of first significant contribution in Nobel Prize, that's growing over time, right? There's this like intuition that it's taking longer and longer to reach the frontier of a field in order to make a contribution.
Right.
And extrapolating that into the future is unsettling. Like at some point, are we gonna like stop being able to pick the low hanging fruit? Then what then, right? If in order to advance the field, requires too much time to get to the edge of it.
So
What's going to
all
happen
Nobel
then?
Prize winners are 150 years old then.
Yeah.
I know, right?
Yeah.
Like maybe if our aging technology keeps up, we'll be okay, right? Like Moore's law, Moore's law for humans.
So it occurred to me
Um,
that once we actually form a base on the moon or on Mars, that virtually
Yeah.
none of our existing systems for weights and measurements and time make sense on those other planets. That the communication between us on Earth here, who we've established everything here based on what makes sense here, it doesn't make sense on the moon or on Mars or any other planet that might be out there. So it seems like that's when all of our kind of our staid communication systems start breaking down.
That could be the natural experiment, right? Once we, if in the next if in our lifetimes we're able to kind of establish colonies in different places and have to restart society from scratch, I think that would be, yeah, interesting to think about how things could be different. Yeah, there's another aspect of how science could be different that I've been thinking a lot about lately, right? So we've got these, I mentioned these simulation studies, right, that try to simulate different structures of science. And one of the parameters that turns out to matter in surprising ways is the proportion of, for lack of a better word, careerists, right? So there's like the truth-seeking impulse, which may or may not be correlated with the careerist, or what I need to do to advance in my career as a scientist right now to get publications. And there's plausible data that matches my experiences in terms of particular biases towards, in a sense, the worst of all worlds, doing mostly incremental work, but dressing it up as novel, and not actually doing it in a useful way. Not everywhere, but these simulation studies try to understand like how robust is the scientific system to what proportion of careerists, right? So how much of the people need to be truth seeking, who will spend the requisite time to really do the experiments, right, and pre-register and do the theory building, instead of submitting the paper to get the next publication. Like I was, I was speaking to this student, some, I think last year, and he mentioned something that kind of haunted me. I was like, would it be great if we made it easier for people to do lit reviews before they write their start their project, to really understand the problem? And he was like, nobody does that. Why would you want that? You would just, the whole reason for doing lit reviews is so you can know what papers to cite, so you can get your publication past the reviewers. And it haunts me to think about what proportion of scientists are doing that versus trying to, when the incentives for publication versus truth seeking conflict, they choose truth over science. And I've noticed that reception to my ideas about metascience and how we can structure the way that we, say, engage with the literature differently in ways that may be more laborious, I tend to get a lot more reception from people outside the academy. So independent researchers, nonprofits, non-academic, para-academic research labs, people who advise governments and so on. And it distresses me how often I hear, from scientists in the academy, I just don't have time to do that. Like nobody has time to sit down and actually think about what literature says before we do something.
To actually understand what the state of the field is. Like we don't have time to do that.
We don't have time to do that. Yeah, exactly. And people say this unironically, and it is strategically wise, right? At least in the short run. And so something I've wondered about as a prompt was, right now science is mostly a career, right? So like it's a career you can go into that puts food on your table. And I think about the correlations between that and, say, what happens to artists when they have to produce art for money as opposed to just art itself. And I wonder about how science would have advanced differently if we had a different proportion of, for lack of a better word, career scientists versus amateur scientists. Like, what if we made it a lot easier for there's tons of people have, like yourself, right? Who have very strong interest in particular fields. And right now, the barrier to entry to advancing the field is very high because not even just like knowledge, but institutionally, if you're not affiliated with a university, it's hard to figure out how to publish stuff. And in that sense, like a huge swath of amateur, I mean amateur not in a pejorative sense, but they're not
Right.
like, right, who have the very desirable quality of not caring if their answer is publishable, but caring a lot about whether they're correct.
So
Uh,
I think maybe we're seeing a bit of a change in that direction. It's very hopeful, I would argue. So
yeah,
I think there's this class of kind of public facing intellectuals that you're seeing emerge in an
yeah,
age where it's relatively easy to start a blog or a YouTube
yeah,
channel or a Substack. And I'm thinking of
yeah,
like Andy Matischak or Michael
yeah,
Nielsen or people
yeah,
like that who
yeah,
have developed a huge following. And
yeah,
Nielsen in particular, he's a former academic, but a lot of what he
yeah,
does nowadays is just riffing on different states of matter and how you might be able to set up manufacturing for
yeah.
things like that, or he does a lot with tools of for thought and cognitive media and things like that. So
Yeah.
I wonder if that's beginning to change.
Yeah, we in our last podcast we discussed the fact that you can no longer buy a chemistry set. That when I was a kid, that chemistry sets were always a big thing for young kids to experiment with and try things, but because they were apparently a little bit dangerous too. So yeah, they've taken them all off the market. So.
When parents didn't care as much whether their children.
Your only chemistry set is a can of Coke and Mentos or something like that.
Right.
Yeah. I mean, think about like all the innovation that came from, people messing around with computers in the garage, right? Like, they're not necessarily they're hobbyists in the non-pejorative sense of the word. So I would like to like simulate alternative futures where you vary the mix of, career traditional like science lab work versus like in a certain sense like part of the that's the premise of citizen science, right? Is
yes, exactly.
trying to broaden participation, but in many cases, I think it evolves quite easily into citizens as data collection helpers for scientists who are doing the real science, right?
Right.
And I think that just scratches the tip of the iceberg in terms of like I was talking to this person who works with families of patients with a progressive disease who are super motivated to participate in the scientific aspect of trying to advance understanding of the disease because their family member, because the disease progresses slowly enough, it's plausible that if they were to help with the research, there's a chance that a cure could be developed in their lifetime. And so there's this huge amount of energy, strong truth-seeking incentives, to really understand what's going on. And I don't think we quite have the institutions to deal with that yet. Like we don't know how to like figure out those collaborations quite as much. In a sense, I'm stumbling into it right now, working with people in the tools for thought space, right? So people who don't care about publication, but they care about improving their productivity or improving their ability to come up with creative ideas. I want to publish with them, right? Because like if you come up with good ideas, they deserve that we should know the scientific community should know about the advance that's come about from even if they're not like affiliated with some university. And I agree with you. I think there's some hopeful signs.
Yeah, I've been speculating that.
Yeah.
Well, I wrote up this concept paper a while back on this idea of the terabyter. It's a person that would whose role in society would be to go out and to upload a terabyte of new information every day. And they would be armed with cameras all over their body and lots of sensors. And everywhere they went, they'd just be absorbing all the information around them. And then that would go into this massive database that we could use to search later. Which that was kind of a pie in the sky idea. So we haven't gone there yet.
Yeah. I mean, to riff on that, like, there's one of the encouraging signs is, so encouraging and discouraging. So, Distill.pub was like a really exemplary effort. They kind of understood the idea of research depth of like we are publishing all this information, and there's not enough people who are trying to make it accessible. The user interface for ideas is very poor. And so their thing was, where are the distillers? Where are the people whose job it is to synthesize, to riff on the idea of uploading a terabyte of information every day, do the job of synthesizing every day so that people like Trent and Joel could find each other, even if they weren't, connected through the same discipline. Right now, I don't know who those people are. So Matt Clancy is trying to do some of that, right? He's got his like wonderful blog where he's trying to synthesize information. The discouraging thing is that Distill kind of shuttered its doors recently, in part because there's a lack of sustainable means for that to happen as a career. And so I think I would like to see a greater diversity of kinds of contributions to science that are different from just like going to the PI track to get a bunch of grants, churn a bunch of publications, but kind of diversifying the portfolio, as it were, of contributions to knowledge advancing. I think that's something I really hope becomes more and more commonplace. I think there's a lot of experimentation to be done there. Yeah.
Well, fantastic. I think that's a relatively upbeat note to end on. Thanks so much for chatting with us today, Dr. Chan, and I wish you the best of luck in your future endeavors.
Yeah.
Thank you so much.
Yeah, this is fun. Thanks.